Alright, what's up, Mr. Dunn? Sorry. Yeah, what's up, Mr. Dunn? Today we're gonna be doing this polar problem. I just took a test, so I should be doing good at this, hopefully. Okay, so I'm gonna be student 1, Dennis is gonna be student 2. Yeah. So my first goal is to show how to graph the first polar curve. Okay, great. So we know that this follows the form. This is the first one. We know that this follows the form r equals a plus b something, which is generally uniform. So we'll start making a table of lines. So if we plug in data equals 0, then we know that the value of r will be 4 since sine of 0 is 1. So we can just keep going like that and plugging in, I just plug in a bunch of arbitrary values. We can do we'll go pi over 6, which would mean that sine of theta is 1/2, and 4 plus sine of 1/2 is around 5.5. And we'll go pi over 2. Then if we plug pi over 2 into this equation, we'll get sine is 1. That means that we'll be getting 4 plus 3 times 1 equals 7. If we plug in pi, it's going to be equal to 0. And 0, so we'll just finish this off and we'll go 3 pi over 2, which is going to give us a sine value of -1, which means that 3 plus 4 times 4 plus 3 times -1 is 4 minus 3, which is 1. And then we'll do last one is 2 pi, which again is the same as 0, and would give us 4. I'll write out one of these equations just in detail, or I just like write. Maybe I'll do it more harder. We can do this. Since we know what we're doing is basically we're putting in r of pi over 6 if we consider this a normal function. If we aren't doing this in a polar equation, this is what it would do, which is really simple and like so 4 plus 3 minus sine of pi over 6 is 1/2, which means it's 4 plus 3 plus 1.5, which is how we got it. not the most accurate graph in the world. Oh wait. Okay. So so we'll say theta. So as it's pointing in this direction, you can see that in this direction, it'll move towards the 1, 2, 3, 4. And then we'll just do pi over 2. And go over 7, so go over 2. And what I'm doing is I'm basically, the way graphing works is that it's graphing polar equations is that you start off facing the x-axis, so it will be the x-axis, and that's our theta 0. And it basically follows a circle, so going back to this would be 2 pi theta, and r is basically the distance outside. So for example here, we're graphing this value to find this point right here, and by doing that we're starting at theta equals 0 and just following the straight line, and we know that we have to go 4 out, so we go 4 out. And then pi over 2 is what I did again. Pi over 2, if the whole thing is 2 pi, then pi over 2 is facing directly upward. That's not directly upward, but you get the point, directly upward. And it goes 7 up, which would be right there. Then we have pi, which would be going out another 4. 1, 2, 3, 4. And then we make 2 pi, which would be going over 1. So yeah, and then what we could do is we could plug in a bunch of other values in between. So you can kind of tell that the graph bulges upwards. You kind of draw it like, you know, kind of draw it like this. And we can test this by saying, okay, this should be like this. And it would go up, it's not the most accurate. It would go up, maybe going about here. Sorry about the bad drawings. I wish I was. And the reason why there's this bulge here is we can check by plotting those points, but we do know that they're uniform, and we know that it goes up. We know that it bulges upwards. So like if for example, if we plotted 4 pi over 3, for example, 4 pi over 3, that means that sine is negative 3 pi over 2. Negative root 3. We get, I did this and we get about 1.4, and that seems like it would be going 1.4 out, and which is more than the one that goes out right here, and that's how we know that there's a little bulge here. And this is from plotting, it would go right about This is just how we know where the bulge is. Like why we know it's there. 4 pi over 3. It's not super accurate. All we need to know is that it's more than 1, which is what it is here. You guys can finish this. Okay, well we know that the max. Okay, well let's talk about maximum and minimums real quick. We know that the maximum is right here. It's at 7, which is why we know that this is what it looks like. In reality, the shape would probably be more like this. I think. Let me try drawing it one more time. Let me try my best. But apart from that, we know that the minimum is at the bulge, and that's when r equals when it equals 3 pi over 2, the graph bulges upwards, and we know that I know I didn't draw it like that, but this graph is symmetrical along this axis since it is a sine graph. This is the, I don't know if this is the y-axis, I guess I'll just say like the vertical axis. Yeah, it's symmetrical along the vertical axis.
Hello, I'm going to be explaining how to graph our second R equation, R equals 4. As you can see, I've already drawn out how the first R equation looks like, the limit here. So I apologize for the bad drawing, and I also have made a table of some arbitrary values over here that represent the first R equation. But I'm going to explain how to do the second one. And first we're going to make our table right here. And then we make sure it's theta on this side, and then R here, this one. Okay, the thing with the second R equation is that R equals 4 is a constant. So no matter what theta that we decide to pick or choose, it is always going to equal 4. So let's say we pick theta equals 0. It is always the radius is going to be 4. Pi over 2 is also going to be 4. Then pi is going to be 4. And then 3 pi over 2 is going to be 4. And then 2 pi is also going to be 4. So no matter what theta values we choose, because r is always a constant, it's always going to be 4. So we can go to our graph here and we just simply start plotting it over. So 0, theta is 0, and then our radius is 4, so we're going to plot 4. Here, pi over 2, 1, 2, 3, 4, and then 4, and then 4. And it goes simply because the second R equation is R equals 4, it is pretty much just a circle. The radius is 4. It is going to be the same all around. So I'm going to draw a circle all around. I apologize for the not great drawings, but it is what it is. So now the next part is how we find our intersections. So I feel like the easy thing to do is simply just set it equal to each other, the two equations. So here we're going to set 4 plus 3 sine theta equal to 4. We set our first R equation equal to the second one. We subtract 4 on both sides, cancel them out. So that would mean it would be 3 sine theta equals equals 0. We then divide 3 on both sides, which would get us sine theta equals 0. Now all we have to do is figure out what theta value makes sine equal 0. And for that would simply just be theta equals 0, pi, 2 pi, and so on and so forth. However, I'm just going to be sticking with these 3 values because these are the ones I will be using later on. So now, for this part, is how to figure out what area we are specifically supposed to shade. And then if we go back to the question here, it specifically asks how to find the area inside r equals 4 plus 3 sine theta, and inside r equals 4. So what this means is that we will pretty much be prioritizing whatever our equation is closest to the origin or on the inside. So here, if we start out at theta equals 0 and make our way all the way over to pi, I'm going to write these down first. Our intersection points 0, pi, and then 2 pi. Right here, from 0 to pi, our inner R equation is going to be 4. So this part is the part that we're going to be shading in. Yeah. And then now we go all the way back to pi, all the way to 2 pi, circling back around. The R equation that is the most inner is the first one, or the so 4 plus 3 sine theta. So that is what we were going to be shading in. And yeah, that's how we would shade in our selected area.
What's up, Mr. Dylan? We're back at it again, taking it over from Dennis Goat. So we know from him that the intersection points of the circle and the limacon are at theta equals 0 and theta equals pi, and we can split this up by going, we know that one full rotation for both of these is from 0 to 2 pi, so we can just split this up and see which one's on the inside for both of them. So we're trying to find which one's on the inside of the curve, and we know that the polar area formula is a area equals 1/2 integral r squared d theta. And by doing this, we can find where the curves intersect, which we know is theta equals 0 and pi. So we need to find which ones are on the inside for each section from 0 to 2 pi. So we would split this up from 0 to pi, and then pi to 2 pi. So from 0 to pi, we know that the smaller one is going to be the circle, because all the r values are above 4, and then all of these values stay at 4 the whole time. So we know that the circle is going to be on the smaller side, so we can set that up by doing area equals 1/2 pi 4 squared theta plus, and now we know that from pi to 2 pi it stays under 4, so we can say plus 1/2 we're not using the other formula, which is like the area between two curves. I don't know if you know that one. I mean, you definitely do. Got this. You definitely do know that one. I forgot you're a math teacher. But
My fault. But this one wouldn't work right now because we're not finding the area between the curves. That would be if we're finding this area. Then we would use that. But we aren't doing that. We're finding the overlapping region, so we're integrating which one is smaller on each radius. Yeah. Great. So this is going to be our final integral, and I'll pass it off to Dennis to put it into his calculator. Yeah. Facts.
Hello, I'm going to be showing how to calculate our integral as well as graph it. So the first thing we need to do is make sure that we're in the correct mode, radians, and then polar, and then we need to make sure that we also use the correct formula, which would be the integral from alpha to beta 1/2 r squared, r is our radius function, and then the theta. I'm just going to do the 1/2 first because it just makes it easier. That's math, and then press our integral using 9, and then we're going to set our first pair of intersection points, which is from 0 to pi. And our first R equation is d4 because it's the most inner. So here, d theta, and then now we're going to do our second integral. Math 9, and then from pi to 2 pi, and then now we're going to do 4 plus 3 sine theta. And then we're going to square the whole thing. And then make sure it's theta. And this is our answer. 33.334. And then if you want to round to the fourth decimal place, would be 1. There it is. So it would be 33.3341. So that's how we would get our answer. And now as for how to actually graph it, we would simply just go to our y, because we already set our mode to polar, and we would just type in our equations. So 4 plus 3 sine theta, and then 4. And this is what we get. Looks pretty similar to what we graphed in the earlier parts of the video. It's pretty much the exact same. We have our intersection points from 0 to pi, and then 2 pi, and so on and so forth. The first part, that is the inner, is r equals 4, and then the second part, that is the inner, would be r and so on. The 4 plus 3 sine theta. And thank you so much for watching this.